Hello everyone, in this video we are trying to follow this book, Cloud-Based Remote Sensing with Google Earth Engine. We're following part A2, chapter A2.3, Surface Water Mapping. In this chapter we learn about this technique called Otsu's threshold technique, and in this technique this statistical method called interclass variance is applied, and we separate the image into two distinct classes. Our objective is to quickly follow the codes, not exactly to follow the codes, but to get the general idea from this chapter. The concepts and the codes are advanced, but this might be helpful for anyone who wants to go through this once. So what we see in the first section of the code is selection of the sentinel-1 dataset, being filtered with the dates and other image properties. We have selected the band VV, and the code's objective here is to draw the histogram. And here the histogram has been drawn here with this function, and the chart type here is the area chart, and we get the counts of different backscatter values. And then we see the function called the Otsu here, which takes the histogram itself as the parameter, inside which we see different process being done with the arrays. So basically it is doing some statistical procedures, and what it results is being shown here in the second histogram with this nicely displayed text called Otsu threshold, and this threshold just divides the image into two distinct classes, that is the water and non-water. And the problem with this is that this might contain the significant portion of those areas which might not be water itself. So there is this suggestion from the authors themselves in this chapter, in which they do the buffer around the probable water area or around the pixel, and only those areas are used to sample the histogram. And what we see here is the bimodal type of histogram. So the main objective of the Otsu threshold technique is to get the bimodal type of histogram, and this type of histogram helps us to group the classes much more easily. And we can also compare the values between two thresholds. And here we see that the global threshold has generally contained so many areas, and this has been circumscribed in the adapted threshold. And finally, the last section of the code compares the resulted areas with the other data sets. So this one is called the GRC data set, and it and this has been compared with the previous 5 years of permanent water. And what we see here is something. So this one is here is the permanent water, and this one is the flood areas. So this method uses the sentinel-1 dataset, which is the SAR-based dataset, and the other datasets which might be from the optical, which might have used the optical datasets. So there might be slight difference, but overall, this is what the chapter tells us about. So I want to conclude a few things. So what we do here is we make the histograms, and we try to make the histograms in the bimetal type, and we find the suitable thresholds. And this is the whole approach of the chapter. And this chapter has the very scary codes if you are new. But anyway, this chapter requires multiple rounds of visits to fully understand the concept. So this was my attempt to cover the chapter. I hope this was helpful. Thank you for watching.